everyone, and welcome to this new episode of the course on solutions for a sustainable world. Today we are again exploring the space of solutions. The course is dedicated to the reorganization and transformation of humanity's metabolism. It follows the episode on energy. It's directly linked, so if you haven't seen it, watch. And to fully understand the reasons that led me to explore all these different solution paths, it is essential to understand the space of problems. So once again, if you haven't watched it, I invite you to look at the space of problems, especially the episodes dedicated to the problems of energy, material, and renewable and non-renewable production. All right, so without further ado, I will start by giving you a very brief recap that does not replace the previous episodes, but is a good way to begin. So, we are faced with a number of problems, summarized here, illustrated by the planetary boundaries model. And in fact, all of these problems can be broken down into two main elements. Those that are due to the fact that we extract too many resources or poorly, and those that are related to the fact that we produce far too much waste or waste that cannot be assimilated by nature. So we take too much on one side and pollute too much on the other. Indeed, these are the two major problems that come with our way of life. And that's what indeed needs to be transformed. That's the focus of this episode of the course. So once again, a quick reminder in terms of scale to get a better idea of exactly what we are talking about. Plastics today weigh more than all the animals on the planet combined together. We have 8 gigatons of plastics and 4 gigatons of animals, which is about double. And then, all that we have built, the infrastructure, buildings, roads, airports, ports, etc., represents in weight more than 1,000 billion tons, which is more than the total weight of the trees and shrubs on the planet. So, we are talking about absolutely colossal orders of magnitude here, principles that are significantly unbalanced and disproportionate in nature. What we need to achieve is represented on this diagram with which you are now familiar. We've already looked at several of the decouplings we needed to make. Today we will concentrate on how we can produce services with less material and services with less environmental impact in this episode, and that is indeed the essential purpose of this particular episode. If we look in a schematic way at what our metabolism corresponds to, all the reactions and transformations we do for our own uses as humanity, we consume resources that are either renewable or non-renewable, coming from the soil, the Earth's crust, the oceans and ecosystems. This includes both living and non-living things. Once they are extracted, they are transformed in various ways. They are distributed, made into products that we use, and then often in the end, unfortunately, they become waste, which causes pollution and a waste of resources, since this waste is not reusable afterward. This is exactly the opposite of what happens in nature. If you take soil, in the fall the leaves drop to the ground. By spring they are completely gone. They have been fully metabolized. They have been transformed by the fauna because the waste of some becomes the food of others. And the natural ecosystems, as we saw in the space of problems, are indeed optimized from a resources perspective, whether it is material or energy. In fact, what we really need to do is to completely rethink our entire economic system and rethink the way we design the system so that it is much less extractive and optimized for the maximum possible reuse of what is produced at the end. This is what we call the principles of the circular economy, as opposed to the linear economy. And from now on, I will give you some examples of things we can do to facilitate this transition from an economy that is mostly linear to an economy that will need to be mostly circular. So, to guide us throughout this episode, a small diagram that I find very practical if it clearly sets the ideas, raw materials coming in, waste going out, the linear economy, that's it. And then we will need to create loops all along. And for that, indeed, we have 3 main levers. The first is to reduce material consumption. If you have less material going in, you naturally have less waste coming out and also less pressure on resources. The second major principle is to keep materials in the economy for as long as possible There are many different ways to do this, and we will look at a few that transform our relationship with various objects and services. Next, the third major lever is obviously to produce less waste, and for the remaining waste, to ensure it is as assimilable by ecosystems as possible, meaning it can re-enter the grand cycle of matter, whether it be living or earth. To start, we will focus on how we can reduce material consumption. In this episode, I am once again only focusing on the material. For energy, please refer to the other episode. A small point nonetheless, if we transition from a predominantly carbon-based world to a decarbonized world, it means that billions of tons of oil, coal and gas will not need to be extracted. So, from a raw material perspective, this whole part, which I am not covering here, is still very important and should be kept in mind. So, to start, the first thing, as you remember, is the same as for energy. The first lever is to reduce our consumption. And from that point of view, you have probably also reviewed this slide that was in the episode on indicators, which you have probably seen. And regarding life satisfaction or well-being, it was observed that money does not bring happiness, at least not entirely, since countries with high income per capita had life satisfaction levels similar to those of countries with much lower income. So today we are going to look at this from another angle, using the same slides, but we will compare countries with different incomes, like Kuwait and Thailand, for example, or countries with different life satisfactions, even though they have roughly the same incomes. And to see this, to visualize this, I will rely on the work of a photographer named Peter Menzel, who, in 1994, did a remarkable job of photographing what the material possessions of an average family were in 30 different countries. So an average family in 30 countries, resulting in 30 photos. And I will present to you 4 of them, the 4 from the previous slide. We will compare Iceland and the United States. Iceland has a higher average life satisfaction compared to Americans. Icelanders have a higher life satisfaction than Americans. Then we will compare Kuwait and Thailand, which have equivalent life satisfaction but very different incomes. In both cases, it indeed materializes into quite significantly different lifestyles. It won't surprise you, but in the United States, the lifestyle is very materialistic, as you can see here. You have a family of 4 with their house, and all the things in the house are placed in the yard so that Peter Menzel can take the photo and we can understand what it looks like from a material perspective. 2 cars, a lot of furniture, and a number of various household appliances. Now, if we compare with Iceland, which has a lifestyle with higher life satisfaction, we see that there are indeed a lot fewer things in the house, at least visually, even though they also have 2 cars. I am now rapidly comparing Thailand and Kuwait in a detailed manner. Kuwait, the advantage of being in the desert is that there is a lot of space. Kuwait is a nation with a lot of petrodollars, where people are quite wealthy, and on average people have a lot of possessions. Imagine the size of the couch. It's an average family. 4 cars for one family. We are in a lifestyle that is very costly in terms of material and energy. We compare this with Thailand, which has the same average life satisfaction, but shows a much more modest level of possessions. We quickly see the difference clearly and evidently between a material efficient lifestyle and one that is less so. And yet the quality of life is the same. So there is indeed something to imagine about consumption or the culture that goes with the use of material. And this is something we have seen emerging for several years. Material possessions do not bring happiness, even if they contribute to it, just like money. Obviously, one needs to have possessions and goods to live in good conditions, but there is an overabundance, a hyperconsumption that is a real scourge in a number of countries. And there is a part of research today for about 20 years that is dedicated to these topics. around voluntary simplicity, minimalism. There are many different words, and all show that people who make the concerted effort in highly hyper-consumer societies to reduce the number of objects in their possession generally experience an increase in their quality of life. So this is something interesting, which is quite fascinating, particularly as we see here for clothing, especially when we consider the context of clothing, because as you are likely aware, it is a very important source. So here, these are figures coming from England. On average, a person living in England purchases around 27 kilograms of clothing each year. The clothing sector is in fact a highly polluting industry. For example, in 2015 it produced significantly more carbon emissions than the aviation and maritime sectors combined. So it's a sector that indeed emits a lot of greenhouse gases, consumes a lot of water, produces toxic emissions in the countries where they are produced, and then when they go through the washing machine, they produce microfibers that accumulate in ecosystems. A sector where it is really important to try to reduce consumption and where there is a lot to be done. So this hyperconsumption that we are in can take on pathological proportions, as there are syndromes like the Diogenes syndrome. If you are not familiar with it, is a psychiatric disorder that affects some people who start to accumulate things in a completely unreasonable way, to the point that their house is totally filled. So that's an anecdote. It indeed shows that our relationship with consumption is not necessarily healthy, and that it is not necessarily easy to establish the right level of what suits us. So on the other extreme, there has long been a development, particularly thanks to Swedish design, of an aesthetic of minimalism, which means how to have an interior and a life that is as simple as possible. Again, this is something that is quite trendy, let's say, with the problems related to the planet. You have probably heard about it. And I found interesting to mention this article that came out in Forbes last year. Forbes is not exactly the favorite magazine of environmentalists. And yet in Forbes there was this article that said it would still be important to be interested in minimalism because it helps with well-being. So there are numerous, various and different online platforms and websites, as well as books that talk about how to do it. I had trouble finding figures on this trend, so I can't document it for you with numbers. On the other hand, among the effects that are systematically mentioned, people adopt more material efficient lifestyles for three essential reasons. Firstly, to make space for themselves and to reconnect. From an economic point of view, it's an opportunity to save money and spend less. And then the third, obviously, is to reduce the environmental impact. The first option is to reduce what we consume as individuals and consumers in our daily lives. And there are also many other levers. And the second one is a model this time that is more for industrialists or companies specifically. It's about how we develop business models that are resource efficient. What does that mean in particular? Let's take, for instance, the example of the predecessor of Dalkia, which was in the past the company that handled heating. Back in the year of 1937, which was when you have this company called Heating Service, who is called by a hospital to solve the heating problems of the hospital. And its business model is to sell coal. So the more coal it sells, the more money it makes. In fact, the hospital is asking not to buy more coal, but for help in solving their heating and boiler problems to reduce expenses, as coal is very costly. The model that Heating Service will adopt is the following. Instead of selling tons of coal, he will ensure the hospital maintains an optimal temperature for comfort. And so from the moment you say, here is your hospital, I guarantee that it will be at 21 degrees all year round, and I make it a point to organize the boiler, buy the coal and do everything necessary. There is an advantage and an interest for the industrialist to save as much coal as possible this time because it will result in coal savings. In fact, the industrialist's margin will be on the reduction of material. So we see that while I'm taking a bit of time on this one, I'll give you two other examples very quickly afterward. What we call the functional economy is, instead of moving from an economy where we sell a mass of material, to one where the functional economy sells a service and saves on material or designs the process so that the material lasts as long as possible and is used in the best way because it is in its interest. This is an example. It's the historical example that I know, but there may be others from before. There are two now, and there are more and more currently. If you want to explore the Environmental Enterprise Award that gives its prize annually every year, we have covered some, and I have noted two. Michelin has proposed a sort of subscription for trucks, so you don't buy tires, you buy a service where you can drive for thousands of kilometers, and when your tires are no longer performing well, you return them to Michelin, who gives you new ones. Therefore, it is in Michelin's interest to ensure that the tires are as efficient as possible, as well retreaded as possible, as well recycled as possible, etc. Carlight is yet another example in a completely different field. Carlight ensures the sale of light and not the sale of lamps, street lights and other similar items. So selling light means that once again they own the lighting fixtures and they must optimize their life cycle. So, one way to address the questions of planned obsolescence that we indeed often hear is to realign the interests of manufacturers with the interests of users and the interests of the planet, ultimately. And to successfully achieve this, one of the effective ways is to create new economic models based on providing service rather than material goods. So now we are going to move on to a second major section, now that we have indeed looked at this one, which is the biggest, which is how we can change our usage patterns to keep materials in the economy for as long as possible. There are links to what we just discussed. One of the direct links is a different way of thinking. For example, Fairphone, which is a mobile phone brand, aims to become the leading brand in eco-responsibility. It pays particular attention to all the materials that will carefully and thoroughly go into the design of Fairphone to facilitate recycling, ensuring that it comes from recycling channels as much as possible. If that's not the case, at least ensure it definitely comes from fair trade to avoid social and environmental problems on site. It is a company that claims, for example, to be electronic waste neutral, meaning it produces as many mobile phones as it consumes. That is, it recycles or uses the components of. So this is an example. We are very far from the big brands that, on the contrary, design in a way that makes recycling impossible. Here, it's really the opposite. Another example, this time it's a kettle, but there are other items. It's a company called Kippet that created this kettle, which is guaranteed for life. Well, it's made to last a lifetime. It's designed to be repairable. They state in their advertisement that it's infinitely repairable and it's in open source development. What does that mean? This means that very often objects we bought at that particular point in time, 5 or 10 years later, are obsolete because they are no longer functional. But many are increasingly no longer able to keep up with the rapid advancements and developments of other technologies. Here, the fact of creating something that is adaptable, that can last over time, is an important factor because it is a form of guarantee that we will be able to keep the physical object longer and that we will not be at the mercy of a small technical or electronic transformation. In my opinion, designing a business model where you sell objects that last, are repairable and can evolve is a model that I find very interesting and indeed quite fascinating from that perspective. We have a first dimension, the fact of having something that is as repairable as possible, as reusable as possible. We have a second dimension, which is indeed how we can design things to be as light as possible. Why this story about weight? Because the more we weigh, the more energy it takes to transport everything, the components, the product, the waste. If we think systemically, the lighter the objects we have, the less energy we will need throughout, on average, throughout, except in very rare cases, throughout the use of these objects. And so, for example, we have talked a lot about batteries. In the course on energy, we see here that you need exactly the same amount of battery power, so the same weight, and therefore the same material needed to make the batteries for a large pickup truck and 250 electric assist bicycles. If you remember, the interest in switching to other modes of transportation, particularly adopting soft mobility, is indeed a matter of energy, and it's also a matter of material, because we will need much less material to extract, transform, produce, and then recycle if we buy a small car instead of a big car, such as mini cars, scooters, etc. This idea that we can indeed make things lighter and smaller is a very important point to be able to definitely reduce the amount of material available for the same service or at least the same use. So there are other interesting avenues. For example, designing materials that are deformable and resilient. Resilient means returning to its original state or shape or form after being deformed. Why is it interesting? Because I think we've all dropped our cell phone at least once in our lives, and thinking about throwing it all away or recycling it just because of an unexpected and unfortunate accident or mishap is quite something. If our technical and electronic objects were better designed to be deformable and more resilient, they would be better at absorbing shocks and would save a lot of material. So it's a very interesting mechanism. There are others that are quite fascinating and truly remarkable. There are materials today that are so light that, for example, this graphene aerogel, this aerogel object, which is 7 times lighter than air, can be supported by a blade of grass. I don't know the species, but it doesn't matter. I think you get the idea. So we can create ultralight objects, and in this case, this graphene aerogel, it is an extremely interesting material with highly efficient capabilities as a thermal insulator. So for various uses where we need such materials for thermal insulation purposes, to render isolating structures, buildings, or to design industrial processes, one could use materials like these. So, this type of material has been known since at least the 1930s, as far as I remember, and yet we haven't really used them because they are too expensive, so we are not at a stage where this can be used, but I am showing it as a potential option because we are not immune to pleasant surprises, as we have seen in the energy sector. So to finish this part on materials themselves, the discovery of new materials or the search for new materials is going to explode in the coming years for a simple reason. I'll give you one. Well, it's more than an example. It's something that fundamentally changes the rules of the game. So the work reported this year by this dedicated and skilled team involves sophisticated and advanced artificial intelligence being carefully and precisely fed with detailed and comprehensive physical and chemical properties of various atoms and numerous molecules. And by learning how atoms combine with other atoms and in what manner, this artificial intelligence proposed the existence of 30 million materials that are not known, most of which are not known today, and on which there is an absolutely gigantic database of possible materials that we could create. What is even more fascinating is that this database provides access to important work, and these various materials are closely associated with their predicted properties. Again, because what works in one case can work in another. And so, based on what we know in physics and chemistry, the relationship between atoms and the way we organize objects, this work will, in my honest opinion, significantly advance the science of materials by discovering new materials with new properties. This can change many of the issues that we are struggling with today, because we don't have the appropriate and necessary materials that are readily available. Another way to truly rethink our relationship with the object and with matter, there is this other example that is also quite incredible. Instead of transporting construction materials such as bricks, cement and wood to build your house, you can print it on site using a 3D printer. As strange as it may seem, the first house that was printed on site was in the Netherlands, in Eindhoven. Here in California, there's another company doing the same thing. You can see the size of the printer. It's quite considerable. In China, it has also developed quickly. It allows for the rapid development of the ability to create objects, including those the size of a house, which is quite crazy, without needing more material than what is necessary for its construction. So you don't have to transport more, and you don't have to create more waste than what is necessary for construction. So this can be of additional interest to reduce the costs, the necessary energy, and the environmental damage that come with construction practices. To quickly continue this overview of new materials or new ways of designing, we can also look at how we can draw inspiration from nature or base ourselves on materials derived from living organisms. In particular, here you have various different materials, ranging from plants like cactus, grapes, pineapples, eucalyptus, mushrooms, living organisms that are not typically associated with leather and that allow the creation of materials that are both relatively easy to produce and, most importantly, easy to degrade, since they do not create waste that cannot be assimilated by nature. It's not just a matter of clothing. We can also design construction materials from plants or animal production. So, for example, from plants, we can now make furniture from hemp because these fibers are very, very strong. We can also design beautiful and intricate furniture or unique and creative decorations using oyster shells. Why not? Or bricks made from oil shells. These examples illustrate transformation logics of the cycle, where the materials that are used are currently not being extracted. Everything that is made from these materials is not made with others. In this example, it saves plastics. So we conclude this quick overview of ways to design differently, lighter, more robust, and easier to degrade. And now we will focus on the more economic dimensions in greater detail, on how we can keep materials in the economic cycle for a longer time. How can we better use the products and components that have been created? And then, essentially, how can we do this more frequently and for longer? The first example is bike sharing. It's an example of material. The material used to make the bicycle will be utilized more frequently as more users start to adopt it. So here we are essentially reducing the amount of material for the service that is provided. The example I chose is this one because La Rochelle created the yellow in 1976. It's not recent. It's going to be 50 years soon. This shows that it has spread widely, since now there are many cities in France and around the world in various regions and locations where bicycles are available for shared use along with scooters and others. This sharing economy is one of the ways to extend usage. There is also the barter economy, which is another way, slightly different, to conceive more uses for the same amount of materials. You have something at home, you don't use it anymore, you can, for example, drop it off on a platform. Here it's my troc, there must be others. The main idea is to connect people who are interested in trading various items for other items that they might find useful or interesting, thereby giving a new purpose and life to these items that would otherwise be left unused and forgotten in the attic or eventually discarded in the landfill. We can extend the usage through other means, such as reconditioning, and because with a mobile phone we also see what the issue is. There are companies in the market today whose primary job and responsibility it is, And this is the specific example I have chosen to illustrate here, to give a second life to a mobile phone by carefully changing its worn out or damaged components and meticulously refurbishing it to give it a second life. We can extend the use of items by repurposing them for different purposes. For example, if you have broken cutlery, you can transform it into a coat rack. These are just a few examples. There are many others. What was the example? An old CD case allows you to keep your burgers for lunch. These are examples that are anecdotal in nature, but the fact of using something for another different purpose is another way to extend the material. An example that is much heavier, for instance, is that of cars, which are significantly heavier in terms of weight. In the transition that will lead from thermal cars to electric cars, what do we do with the thermal cars? The first way is to scrap all the vehicles and then try to recycle as much as possible. There is another method called retrofit, which involves transforming a thermal car into an electric car. For that, the engine needs to be replaced and the fuel tank needs to be replaced with a battery. This is something that is technically possible today, although it remains a bit expensive, so it struggles to develop. However, we could imagine that in the future it could develop much more because in this case the uses are considerable. In France there are about 40 million vehicles on the roads. If we had to scrap everything and start over, it would represent an absolutely gigantic waste of energy and materials. So we can indeed imagine doing things differently. And that actually brings us to the next topic, which is in this cycle of matter. How can we extend its use to the maximum? We have seen how we can extend the use of the same object, either by transforming it, reusing it, or using it in different ways. We can also completely transform the object by degrading it in various ways and recycling it. In the realm of production, the process encompasses recycling, and we will delve into the concept of valorization, which involves enhancing the value of recycled materials. Finally, we can also, as we approach the end of the cycle, develop industrial processes to be much less polluting, since we have talked a lot about materials, but there is obviously the question of waste. So that's what we're going to look at now, and we'll start by focusing on the metals and materials that are absolutely essential and crucial for the energy transition. As we discussed in the previous episode, electrifying various technologies and processes will create a high demand for metals. The shift towards electrification requires significant amounts of different metals. For instance, the International Energy Agency informs us that an electric car contains more than 4 times the amount of metallic materials compared to a conventional car, including metals and graphite. This highlights that producing electric cars requires a substantially larger quantity of these materials. So it's essentially copper, a bit of lithium, a lot of nickel, manganese, cobalt, and a lot of graphite. The metals that are essential for the production of today's electric car represent a significant investment in metals. This is also the case for the devices we need to produce energy, whether for wind or solar power generation systems. These technologies require significantly more material per megawatt, MW, produced compared to nuclear energy systems and thermal plants such as coal-fired and gas-powered stations. So again, with significant differences, in the case of wind energy, it's mainly copper and zinc, and for solar energy, it's copper and silicon. The energy transition requires large quantities of metals, which raises several questions. Will we have enough resources? How exactly are we going to produce them? In the net zero emissions scenario I mentioned in the previous episode, our material needs are going to increase significantly, particularly because of the growing demand for solar energy, but especially due to the rise of electric vehicles and the batteries needed for electric vehicles and the operation of the grid. And this growing demand will translate into a significant increase in the need for certain essential metals, notably lithium, which will be required 40 times more, graphite, cobalt, nickel, rare earth elements, and others, especially copper, which is crucial for various applications. Without being exhaustive, we can clearly see that transforming the system from one that extracts a lot of material and fossil energy to one that will extract a lot of metals. However, we will extract significantly less metal than we need in fossil energy. We are talking about the order of 1 billion tons in fossil energy and about the order of 1 million tons in metals, 1,000 times less. We are not exactly on the same scale. And the question, of course, is whether there is enough material in the Earth's crust. So, generally speaking, on this question, experts, in their professional opinion, tend to adopt a positive and favorable general consensus. This conclusion aligns with findings from both the International Renewable Energy Agency, IRENA, and the International Energy Agency, IEA. They agree that while there are sufficient metals in the Earth's crust to meet our needs, market tensions may arise due to the current production capacity, which is inadequate to support the significant increases in demand. And so, once again, the less we need to extract metals, the better, because it's going to be quite challenging. It's more a question of time and extraction capacity than a question of resources themselves. Moreover, each extraction also produces a significant amount of pollution, especially rare earth elements, and so anything that helps save the resource is welcome. To give you an idea of the masses involved, I was talking about billions of tons and thousands of tons. If we take all the metals in the world, fundamentally, what we extract massively is iron. In fact, the metals we will need for the energy transition are copper, nickel, zinc, and then rare earths, cobalt, molybdenum, lithium, etc. The quantities remain very, very small. So even if we need to multiply by 10, 20, or even 30, it remains significantly small compared to those scales in any case. And so we naturally arrive at what will now be the core of the topic. The fundamental question is that of recycling. Because it's not just about extracting these metals, but it costs a significant amount of energy and resources, and it emits a considerable amount of pollution, and it causes numerous environmental supply issues that accumulating what has been extracted from the earth in landfills makes no sense. It might make economic sense today because it is too expensive, but these are sectors that absolutely need to be developed, and that is the essence of all the analyses on the subject. So, for example, the International Energy Agency emphasizes just how fundamental it is to develop recycling, because today the recycling of some metals is like this, meaning that we recycle silver, gold, platinum, nickel very well, and in other various important metals. To a lesser extent, silver. We see that we don't recover everything either. There is still room for improvement. But for other metals like zinc, cobalt, or chromium, we are already down to 30%. So, in quotes, the margin for maneuver is considerable. For certain crucial elements needed for the transition, such as rare earths and lithium, the current supply is minimal, nearly non-existent. These are sectors that must be developed not only to enable this transition, but also to ensure sustainability. And that's it. Energy transition under good conditions. So it's being implemented little by little. Here, the photovoltaic panel sector is booming with different methods, I won't go into details, that allow for the panels to be taken back and turned into materials that will allow for new panels to be made. So this is not just reconditioning, it's also complete recycling. And on the issue of metals, one of the countries that has made significant progress in recent years is Japan, which has implemented a recycling policy for about 20 years. They have developed what they call urban mines. That is, there is a huge amount of electronic waste, as we have seen how important it is. This electronic waste is actually very, very rich in metals of all kinds. And Japan has calculated that the amount of gold and silver accumulated in this waste represents absolutely gigantic volumes, more than 6,000 tons for gold and more than 60,000 tons for silver, which is absolutely gigantic. To give you an idea of the scale, this is the amount of gold and silver available in electronic waste in Japan. This quantity is indeed greater than what is estimated in the reserves of mines in South Africa. So actually, going back to the process of extracting valuable metals like gold and silver from a traditional mine, or extracting these precious metals from what Japan refers to as urban mines, which means industrial waste materials, is soon going to be the same question. The question is, how do we significantly increase this recycling process to make it more efficient and effective in recovering these valuable resources? And to give a more detailed and comprehensive quantitative overview of what this represents and to provide an illustrative anecdote, over the past 2 decades, the amount of electronic waste that has been reused to extract metals has been continuously and steadily increasing at a significant rate. This trend highlights the growing importance of recycling and reusing electronic waste to recover valuable resources. And in 2020, for the Olympic Games, the medals were made with metals that came from these urban mines. So we have a lot of progress to make on metals, but it will become even more important as the pressure on these metals will be very significant and the amount to be extracted from the primary resources, from terrestrial resources, will diminish. To move on to another topic that is different and rarely discussed, but is important because it is by far the largest volume, the biggest mass of waste we produce. These are construction waste. In France, it represents 70% of the waste produced. These are construction waste, including various types of rubble, planks, and so on. And we actually do quite little with it. So it's ongoing, and once again, for at least the past 20 years, it's something that has developed more and more, and the amount of waste produced is decreasing year by year. But I wanted to share with you 2 initiatives that I find interesting. The first one is the company Cycle Terre, which will be working on the Grand Paris Tunnel project. The tunnels of Grand Paris involve 40 million tons of earth. These are incredibly monstrous volumes. What do we do with this earth? This company has indeed imagined being able to actually take this earth and, at the moment we dig the tunnels, use this earth to create materials that they can use to make buildings. So at that moment, we have something that fits into this circular vision of using waste as a resource. At the local level, once again, we save a lot of energy. We don't need to create cement or bring things from here and there. So it's quite interesting in a completely different context. Another initiative from a well-known French company called Neolith. And Neolith has created what they call the Anthropocide. The Anthropocide is literally the human rock, and they fossilize it. That's the term they use. They use waste and utilize various methods and techniques in order to create durable and sustainable stone, or at least construction materials from waste. Once again, we're focusing on how we can utilize waste, specifically waste that has value. We certainly won't pursue this with waste that lacks value. Industrial waste, but with waste that no longer has any value, such as residual waste that has no market value and that is often considered to have good resistance. How can we recompose them in different ways to make construction materials? So always this idea of taking waste and turning it into resources. Finally, to very briefly wrap up this overview of the issue of recycling and waste management, I will show you a couple of slides on household waste, because this is the state of our trash bins. In fact, actually, on this slide here, our household waste can have various fates. By default, it usually ends up in a landfill, often indicated by a pink bin in most cases. So this is indeed the least interesting level, because not only do we pollute, but we also don't actually use anything that was inside. So here the countries are ranked in this study. The countries are ranked from those who use the most waste to those who use the least waste. And what we observe is that Obviously, the countries are very different from each other, but the trend of going to landfills, for example, which is currently the trend in the European Union, at least it's the rule, is diminishing. And there are a number of countries that have completely stopped landfilling. It is replaced by two distinct elements, which are essentially three things in total, even though there are only two colors involved. We can either recycle non-organic waste, which is often represented by light green, and compost organic waste, which is indicated by dark green. By incinerating non-organic waste and recovering this energy to, for example, generate electricity or urban heating, such as for homes and businesses. So either we use it, recycle it, recover its energy, or do nothing with it and it's in pink. What you see then is that countries are very different. In Europe, there is a tendency today to maximize composting, recycling, and when there is no other option, incineration, but there is almost no more landfilling. And this trend is a fundamental one, which has allowed us to make really significant progress, because here, well, I'm sorry, but it's not the same color code at all, so let's start over. Back then, in the 1990s, landfilling represented the majority of waste disposal methods used. Today, in Europe, it represents only a very small minority of waste management practices. What has developed is incineration, recycling, and composting. So we either have recycling of materials, organic or inorganic, or energy recovery from materials. In any case, the situation is improving significantly over a relatively short period of time, since we are talking about 20 years, for processes that are still quite complicated. And I conclude on this issue of waste by noting that industrial processes are also evolving relatively quickly, and that, for example, the CITEPA report on atmospheric pollutants in France shows that, with the exception of one gas, all atmospheric pollutants in France have massively decreased since the 1990s. The rates of decrease vary significantly. Some have decreased by 50%, others by 75%, while some have experienced reductions of over 95%. Fundamentally, emissions into the atmosphere from industrial processes have significantly improved since the 1990s. This progress is largely due to ambitious regulations and policies that have implemented various measures, including advanced technologies and cleaner production methods, all of which have been rigorously enforced. While there's always room for improvement, it's important to reflect on the progress we've made over the past 30 or 40 years in adopting different production methods and reducing toxic waste emissions. So we have seen how to reduce material in various ways, how to maximize usage, and how to try to minimize waste. We can also draw inspiration from nature to implement various strategies, a concept known as industrial symbiosis or industrial ecology. This involves combining the production cycles of different entities to create a more sustainable system. A company that produces certain waste will have that waste used by another company that will produce other waste, and so on. That is essentially what an ecosystem does, where material flows pass through different organisms that constantly and continuously exchange matter and energy. The most well-known example of this, which is a prime example of industrial symbiosis, is Kalundborg in Denmark. Kalundborg is an exceptional example of industrial symbiosis, as it began in the 1960s and has continued to grow ever since. This remarkable initiative showcases the long-term benefits of collaborative and sustainable practices. And it's an industrial setup where you have many different companies in various sectors doing different things and processes, but needing each other and optimizing the amount of energy, water, and materials they need to achieve optimal efficiency and resource management. This is because if you have one of the companies that, for example, releases heat, another will need it and use it through collaboration and interdependence. This concept also applies to water, which can be used by one industry and needed by another. For example, you are managing a diverse group of companies that are dedicated to maximizing the efficient industrial use of various materials and energy resources in a sustainable manner. It's truly a textbook case. It's so exemplary that visitors from all around the world come to study these setups. However, there are currently very few replicates of this model available. They claim there are 170 other instances of industrial symbiosis worldwide, but it's challenging to find strong examples. One notable case is detailed in a publication I was previously unaware of, which discusses the biorefinery located near Reims in Pont-Maclé-Bazancourt. This facility exemplifies the same principles of industrial symbiosis, featuring various companies, including a sugar refinery and liquid air. We are handling very different sectors of activity, but they come together. The waste from some can serve as raw materials for others. So, it's something we can imagine developing in the near future, even though the most noteworthy example dates back to the 60s. We can hope that industrial ecology projects will develop in the future. So, it's not limited to the land. There's indeed a project at sea that I found very fascinating, which to a lesser extent is also a symbiosis project. In the Bay of Saint-Brieuc, the local fishermen do not want wind turbines in their area, so they have proposed a well-thought-out alternative model where the natural wave energy is efficiently captured by a specially designed wave motor system, and this harnessed energy is then utilized to produce clean hydrogen in an advanced electrolyzer. And this hydrogen can be used directly and efficiently for boats if the entire fleet of boats switches from fuel to hydrogen. But by doing this, we also produce valuable oxygen. Once water is electrolyzed, you get hydrogen and oxygen. So how can this oxygen be utilized? They designed a device where this oxygen could be injected into fish tanks to oxygenate and boost fish production. So create sustainable aquaculture farms with energy production and an efficient distribution system for boats. So there is indeed this idea that we don't just perform a single function. We actually design an entire system, a whole comprehensive ecosystem of services around it, to entirely and ultimately maximize the use of material and energy. It's always the same principles. I don't know if this project will come to fruition, but I found it interesting to mention something very different from what exists in Denmark, but which, in a way, is inspired by the same principles. So, we have talked a lot about industrial processes, but there is also another way of looking at things that is very complementary, and we will see some examples of this. It involves basing our approach on nature, not just in abstract terms, like in the case of symbiosis, but physically relying on nature, developing natural services for a number of applications. This is what we call nature-based solutions. In this diagram from the World Resource Institute, what is presented is a list of possible solutions based on ecosystems. We see this in various forests, rivers, cities, coastal areas, etc. Each time we have different applications, and I have carefully selected 3 for you that thoughtfully illustrate how investing in nature can significantly increase services for populations. The first one is green spaces in cities. The second focus will be on the extremely significant forests and watersheds. The third will highlight the crucial and vital mangroves along the coast. First, let's discuss green spaces in cities. Planting a tree in a metropolitan area, and especially developing forests or wooded areas, goes beyond mere aesthetics. It produces various and different services that have been listed here by an American municipality. The more trees you have in urban areas, the more you can significantly and effectively prevent water runoff during heavy and intense storms that can wash away all the harmful pollutants and potentially, for instance, cause flooding. You can also lower the overall temperature, which is significantly valuable in these times of climate change. You can significantly reduce air pollution because the plant will capture a lot of pollution. You can significantly and effectively reduce air conditioning costs because you are overall lowering the temperature in the area, which is known as urban heat effects. And then it absorbs CO2, and thus, once again, you have an effect on air pollution and especially on the atmosphere. Locally, it is a way to help limit greenhouse gas emissions in our local community effectively. However, the benefits of green spaces extend beyond just reducing negative impacts. They also enhance many positive aspects,
Research shows that homes near green spaces tend to have higher real estate values, which is particularly appealing for residents. Additionally, these areas contribute to increased biodiversity and improve the overall health and well-being of the surrounding population. And then it even significantly enhances learning and concentration in various ways, showing that we all need a little bit of nature at home for our overall well-being. Another example on a much larger scale, which is indeed perhaps less well known, is that of New York City. So New York indeed is a very large city that needs a lot of water for its residents. And there, by default, in order to produce water, we build water capture plants that treat and effectively supply the city with water suitable for consumption. So this is an industrial model.
It turns out that New York did not, in fact, make the decision to opt for that choice. What the city did, actually, was buy land in watersheds, specifically in the mountains upstream of the city, namely the Catskills and the Croton watersheds. These watersheds are areas where forests and lakes help supply the city with water via the rivers. And what does New York do? New York buys these places, protects their development to ensure the quality of the ecosystems, and then develops water pipelines that draw clean drinking water from the large reservoirs of these lakes for the city. So instead of investing in an industrial process, the city invested in preserving the upstream ecosystems to ensure the quality of its water.
Another example that might be more well known is that of mangroves, which are in fact extremely useful for stabilizing coastlines, as they are one of the best means to stabilize coasts.
Currently, it is the non-governmental organization known as Friendship, operating in Bangladesh, that has undertaken the largest mangrove restoration project in the entire world, and therefore involves local populations in massively and extensively replanting mangrove trees and rebuilding this natural barrier that has many different and essential functions. One of these functions is to stabilize the coast and provide protection against maritime influence, particularly during severe storms when the sea encroaches on the coastal areas, salinizing it and thus greatly preventing agriculture from developing.
So you have a way, once again, to provide a service to the population by restoring ecosystems in a beneficial way. Finally, we will look at how we can also rely on nature in various different ways to clean up pollution.
There are many different organisms, such as bacteria, fungi, and plants, that are capable of metabolizing pollutants in various environments, breaking them down through complex biochemical processes, and using them as a source of energy.
In this paper, which provides a kind of synthesis of what exists, there are various different processes. We won't go into detail, but fundamentally, when you have contaminants of any kind, you can either stimulate the growth of bacteria or fungi by adding water or nutrients in order to degrade the contaminants, or you can take it a step further and add bacteria or fungi that are missing in the soil to degrade the contaminants in a manner that is effective. When dealing with highly polluted lands, it's possible to accelerate the ecosystem's recovery by leveraging a good understanding of the local flora and fauna, as well as the specific contaminants present. By stimulating or enhancing the natural processes of these ecosystems, we can facilitate a faster remediation process. So this is essentially what we can do at the soil level, primarily with the soil microfauna, such as bacteria, fungi, etc. And then you also have different kinds of methods that work with plants. Remediation is the use of natural processes to clean up pollution. You can bioremediate in a variety of different ways. Phytoremediation is the one method that plants use. There are many different ways to do it, but the underlying principle is always the same. As it grows, the plant will extract and draw resources from the soil and either store them, degrade them, evaporate them, transform them, and ultimately allow the ecosystem to recover. In this coal power plant in Serbia, you initially have a soil that is basically sterile because the coal power plant has produced so much ash, along with an astronomical number of pollutants, that the entire natural ecosystem is non-existent. There are absolutely no plants growing at all. By systematically and carefully replanting species that can thrive in harsh and extreme conditions, we can achieve an initial level of decontamination. After this first phase, we can introduce a second wave of plants. Sometimes we can simply help the natural ecosystem to recover by supporting natural processes and promoting biodiversity through careful management and restoration efforts. Within a decade, we can have a functional ecosystem again. So it's something that works well, phytoremediation. In many cases, we are here. The drawback is the time required. Generally, industrialists typically want to decontaminate more quickly to build and therefore use more industrial techniques. But biological techniques work extremely well. If not better, they just take time, and these can be useful in many cases and scenarios and situations, and we can hope that it will develop in various situations. Another application in a sector that is not industrial but in a city, bioremediation and phytoremediation of waterways. Here we are in the Philippines. You can see before and after treatment, we are not dealing with the same type of habitat at all. So how can we effectively reuse the elements of nature to clean up our environment? How can we literally bring life back to natural spaces and urban areas, such as parks, gardens and city streets? It's part of the possible solutions that are available. And then to finish on this topic, it's not just a matter of depollution. Plants can also be used in a multitude of ways to concentrate certain resources. And this is indeed particularly the case with a very unique and special type of plant in New Caledonia, the Pycnandrus, which are plants known as hyperaccumulators. Here you see various different species. When they are cut, they secrete a kind of milky substance of rubber, and the reason why it is blue here every time is because this latex contains an astronomical amount of nickel at concentrations that were unimaginable before people measured it. So this type of plant is capable of bioaccumulating possibly pollutants and, in any case, in this instance, metals such as those that are in the soil. And it can be useful both for phytoremediation and perhaps we could imagine various different applications for potentially extracting metals. So we've done a quick overview, but I hope it was diverse enough to give you some ideas of the possible avenues throughout the entire cycle of what can be done. And what I would like to do in the last part is to take a specific case, the case of plastic that we saw in the problem space, to see how these different approaches can be complementary. So regarding plastic, I invite you to reconsider the scope of the problems. This is one of the most important problems for us because it is a material that is so very good, in quotes, because it is unbreakable, cheap to produce, can be deformed, and can also be made into whatever we want. Since the 1960s, it has spread so much that, as was indeed initially stated, 8 gigatons have been produced. Global plastic production now exceeds that of animals, yet it poses colossal pollution problems because fundamentally a large part of it is waste. And I think this is significantly important. Is thrown away, very little is incinerated, and very, very little is recycled. So how can we indeed try to address these plastic problems? There is a paper published in the year 2020 that evaluated various different scenarios in order to minimize plastic pollution as much as possible. The first conclusion is it won't be possible to have zero plastic. The second is we can try to get as close as possible. For that, the only solution is to combine approaches, which should no longer surprise you now. So here in this figure, as you can see, there is this very famous combination. The first lever is to actually reduce plastic consumption. Well, it seems obvious, but even by doing this, we won't be able to solve all the problems because some will remain. As there are uses, we don't know how to do otherwise. So the second is to produce various other types of plastic and thus substitute plastic with something else. The third is to recycle different plastic materials. The fourth is to dispose of waste in suitable, safe locations that are free from contaminants and significantly reduce the amount of plastic that ends up in ecosystems. While it's inevitable that some plastic will remain, our goal should be to minimize it as much as possible. If we continue with current practices, as illustrated by the presented curves, we can see that if we take no action, the red line indicates a catastrophic outcome. So trying to minimize as much as possible is achievable by combining different approaches.
So what does that mean? Avoid plastic. Here is the world map of countries that have banned single-use plastic bags. So we see that it's going relatively fast now. It took some time, but now it's going relatively fast.
In blue, these are the countries where plastic bags are completely banned. In light blue, those are the countries where they are partially banned. In orange, they are banned in certain specific cases.
So there is still a long way to go, but you can definitely see the glass as half empty or half full. It's still a good start.
So then how can we substitute? We can develop plastics inspired by or based on living organisms which have the ability to biodegrade.
Now, you have to be very careful because there are many things that are called biodegradable which are not at all. So you have to pay very close attention to the labels, but there are some very interesting examples indeed, and it's something that's developing very quickly. So this is actually one example, but there are obviously many. But this material really decomposes in water in just 10 days.
So for disposable uses, in quotes, everything that should be avoided, we avoid it. But in uses where we need the plastic to be able to degrade very quickly, we know how to make types of plastic today that are indeed capable of decomposing very rapidly.
So another example, for instance, in Toulon, there is a soccer field that was inaugurated with artificial turf that is not made of plastic, well, bioplastic, the plastic in question being made from olive pits.
So we are looking at new compounds, new and innovative and advanced ways of recycling, using biomaterials as we mentioned at the beginning, thus substituting uses with biomaterials. A third example is the innovative company Notpla, which creates environmentally friendly packaging devices from algae. These unique packaging systems are designed to dissolve in water after a certain period, making them highly sustainable. This process allows the use of a resource of growing interest, algae, to produce necessary packaging systems while transforming their usage so that they are easily assimilable by the environment.
So another major aspect is how can we recycle? Here again, the countries in the north often show us an interesting direction. In Norway, 97% of plastic bottles are collected, which is very important.
They have collection devices in their large store, and when you bring back your plastic bottles, you get tokens that allow you to buy more plastic bottles and other similar items, etc.
So this deposit system, which indeed worked very well with glass bottles in Europe in the 1960s and 1970s, has gradually disappeared. It's something we can bring back, especially for plastic, to prevent there from being too much of it in nature.
Additionally, we can't rely solely on recycling plastic. We should also explore innovative ways to repurpose it. In many cases, we can find new uses for plastic that extend its life cycle. Madame Matei, a visionary entrepreneur, has created a groundbreaking company in Kenya where she innovatively uses recovered plastics to make eco-friendly and sustainable construction materials. We also find a bit of the idea we had earlier of turning waste into a resource and indeed being able to actually build new habitats with bricks made from plastic.
So thanks to this innovative and efficient system, it creates something even more interesting and beneficial than just recycling itself. It creates significant and impactful value for something that requires recycling and thus leads to more and more plastic waste materials ending up with her to be transformed into valuable and useful construction materials.
And then we can significantly increase the overall degradation process of plastic or assist in its treatment. So there is recently conducted research on various different organisms that shows that some organisms have been shown to be able to learn to break down plastic. This is indeed the case for certain enzymes, some fungi, and even some insects. So for now, it's still at the experimental stage. But here, in this particular publication, they showed that bacterial enzymes were capable of breaking down plastic with very good efficiency. So I'll end on that very positive note. This is one of the papers I find most extremely and incredibly fascinating on this topic, which came out last year. It is a paper that studies the ability of ecosystems to digest plastic. Because even if we manage to completely stop plastic production and its emissions on the planet today, there is already so much plastic on land, and especially in the sea, that it poses colossal problems. So how will nature in the environment manage this new waste, but also with this new source of energy? Because plastic is essentially just long chains of carbon molecules, and that is very rich in energy. So one day a bacterium will find a way to eat that. So how long will it take? That's the question. If it takes millions of years, that's obviously very long. But what this paper shows, what they did, is that they conducted in great detail a sampling from the four corners of the world, as you can see all the points there, of water or land, and they went to collect all the genes that microorganisms possess in each and every one of these samples, thoroughly and extensively, from various regions, meticulously and comprehensively. That represents 200 million genes. To give you an idea of the scale, they did a colossal mapping job of ultimately, in this water here or there, what types of living beings are present and what genes they express. And they compared these 200 million genes to genes known for degrading plastic. So there are indeed many different families of enzymes, but let's say 30,000 genes are known to degrade plastic. And what they showed is that in 1 out of 4 cases, so indeed in 25% of the cases, these samples actually had genes capable of degrading plastic. So it is possible that nature is already figuring out how to break down and consume plastic in various ways. But what supports this hypothesis is that the places with the most plastic are also the places where we find the most genes that degrade it. So it seems that the various bacterial microflora around the different parts of the globe are adapting. It doesn't tell us how long it will take, and it's certainly not a reason to stop doing everything else, quite the opposite. But it also gives a bit of hope of the system's resilience. We have already seen it with ecosystem restoration. Nature is extremely resilient, but we need to give it time. To conclude, as you can see, it is quite simple. The first thing to do is to avoid producing waste in any way, to avoid over-consuming material in any form. So everything we can avoid doing is good in any way. Then, when we are really obliged, reduce the amount of material we need, reduce the amount of waste we will produce. Then, once the material is already in the economy, everything that we can do to reuse it will be extremely important in any way possible. When a product reaches the end of its life and can no longer be used, everything we can do to recycle its components and materials is really, really important. What remains at the end, because we have truly gone to the very end of the chain, we can value it. To valorize it means, for example, to burn it to recover energy or to find a solution so that it still has some value. And if we really can't, we throw it away. But if we follow this logic, we will significantly reduce the amounts of material needed in the different parts. To enhance this model, inspired by nature, we can reorganize our systems to ensure that everything we discard can be integrated into other life forms. This approach allows discarded materials to continue serving a purpose, ultimately benefiting the ecosystem. In conclusion, to conserve and protect resources while minimizing the impact of our waste, we need to focus on 4 key actions. First, we must critically evaluate our usage and aim to reduce our material consumption. The second is to completely rethink the way we produce and use resources in a comprehensive manner. The third is to develop new technologies and innovative new materials to replace what we have today. And finally, it means taking as much inspiration from nature as possible to design and depollute, because that's still what works best. And if these topics interest you, I can recommend subscribing to Horizons and FE News, which are two media outlets that are particularly concentrated on these concepts and will provide you with many examples every month of what works and how our behaviors and legislation are evolving and changing.